Thanks very much, and welcome to the NASA exhibit at the 2023 AGU. We have a whole great suite of talks this afternoon from our leadership and our division leaders. And we're going to kick things off this afternoon with Dr. Nicola Fox, Associate Administrator for NASA Science.
Thank you. It is a great pleasure to be here today to kick off the Hyperwall, and I actually get the best job because I get to debut the planning guide, which is by far the best thing. I hope that you've all had a chance to get one. They're handing them out at the door, and they'll have them on the booth all week. So please come and take one home. So first of all, this is our cover image. And so thanks to Jenny Moda and her team for the incredible work that they do. As always, there's lots of little hidden things in this image. It talks about all of our divisions. You can see obviously the sun with the eclipse. Clearly you cannot have an eclipse without the moon, so that is bringing in our planetary friends. Our person here is standing on the Earth to view the eclipse. Nicely done. Thank you, Karen. You can see the Milky Way for our astro people. Come on, Mark. Woo! All right, thank you. And over in the bottom here, wrapping our biological and physical sciences, you can see the plant Arab Adophis. Somebody help. I had it before. Anyway, that's what it is. I will also say, because Jenny puts a lot of little hidden things in here, you will see a fox down here. My favorite bit. And I will actually also fess up that this is my daughter. So it's a very, very personal calendar this year. It's obviously exciting for me. It's the first calendar as the AA. I've been in the job 9 months now, and I'm loving every minute of it. So I'm going to highlight one image for each of the divisions. That means that you have to actually go get a planning guide so you can see the other images. Whoops. Okay, so we'll start. I'm sure that this is the January image. So this is our astrophysics image. I'm sure you've all seen this. This is Ru Ophiuchi, and this is our 1-year anniversary image of the first light image from the James Webb Telescope. So this is actually, it's our closest star forming region. It's about 360 light years away, and it is described as a sort of quiet, small stellar nursery. But if you actually look at it, it doesn't look very quiet. You can see jets shooting out from the stars as they're being born. You can also see sort of the telltale disks of like the galaxies that are forming in there too. It's just a spectacular image showing us not only the amazing work that the James Webb Telescope does, but also just showing for me the sheer beauty of our universe. If you don't look at this and see beauty, I don't know what's wrong with you. All right, so into February. I believe this is the sun. Somebody might have to prep me on this one. All right, so this is a beautiful image of the sun taken by the Solar Dynamics Observatory early this year. You are looking at a very beautiful X-class flare. You can also see many, many, many active regions, many things that could turn into very large space weather events. So this is an X-class flare, as I said, which is the largest of the categories of flare, leading very frequently to a large-scale aurora, beautiful aurora that we see here on Earth, but also can cause major issues for our technology. And so the Heliophysics Division working to be able to help us predict this very, very intense space weather. So this is actually showing as well the increase in solar activity as we move towards solar maximum, predicting that we'll see solar maximum sometime next year, which will be during the heliophysics big year. That kicked off in October with the annular eclipse. It will include the total solar eclipse in April of 2024. We hope about 300 million people will experience that total solar eclipse, and it will finish with the coolest, hottest mission under the sun, Parker Solar Probe, making its closest approach after the 7th Venus flyby. So lots of excitement for heliophysics. And this is for, where's Karen? Earth science, okay? So you're looking here at this extremely beautiful, thank you for the enthusiasm. So you're looking at an image taken by Landsat in April, and the sort of the turquoise and the greenish colors of the phytoplankton, which are little organisms that have a really profound impact on us as humanity and also on our planet. The plankton is something that we really, really, really want to study, so much so that we are getting ready to launch the next big mission in Earth science, the plankton aerosol sea. Pace, I've forgotten C. Clouds, thank you. And ecosystem. I swear I read my notes. Anyway, PACE will launch early in 2024. It will be adding to, as we start to really grow our Earth System Observatory, so we can piece together all of the really important parameters that go into our climate research as we sort of protect our planet for humanity. And this is a very unusual image, one that you probably haven't seen. So this is from our Biological and Physical Sciences division. And what you're looking at is bipolymer scaffolds. And you're looking at them really, really close up. These are teeny tiny little micron structures. And you can certainly see these amazing loops. And you're looking at kind of wrinkled cell walls, which honestly makes me want to go home and use moisturizer, but there we go. So this is a beautiful image, just some of the really, really great science that we do up on the International Space Station. Biological and Physical Sciences just got their new decadal survey, and it's exciting to be working with the division as they get ready to kind of do their roadmap for how they're going to address all this really great science. One of my particular favorites is tissue chips, which is taking, so this research is done on the ground. So it's kind of getting the experiments ready to go up into microgravity. And one of these is tissue chips, where we fly little avatars of human organs. And we can actually look at how they respond in microgravity. And it will actually help us advance our medical research. So yay for BPS. And then it was a difficult choice for me of which one I chose to represent planetary science. In the end, I decided to go with this one because it really illustrates everything that we do in the Science Mission Directorate. So this is very cross-divisional. It is an image of Jupiter, clearly. It is taken by the James Webb Space Telescope. It shows very beautifully at the top and at the bottom that Jupiter has aurora, just like we see driven by space weather here on Earth. And then you can see the cloud structures and actually the big red storm. They look white because they're reflecting the sunlight. This was actually taken as part of the Open Science Initiative, when the community was able to choose basically what James Webb imaged early on, with the only proviso that the data had to be released immediately. And so that fits right into our open science. 2023 has been the year of open science in SMD, as we lower the boundaries and welcome more and more people in to share the excitement of NASA science. And I'm going to finish with an iconic image. So this is taken by the NOAA GOES spacecraft. So it's part of our the work we do with our Joint Agency Satellite Division, and where they actually handle the acquisition for NOAA. So this is the 50th anniversary image of the marble, the blue marble. And when you look at this image, this is I think is a stunning image. This was taken, so the original one was taken from the Apollo 17 mission, and 50 years later, we're taking very similar images. And when you look at this, you kind of think that everyone and everything that we've ever experienced is actually on that tiny planet. So whether you think of it as the blue marble or the pale blue dot, when you look at it from space, you don't see boundaries, you don't see conflict, you don't see challenges, you see beauty and fragility, and it makes us all think that we should work together to actually protect humanity and look after our planet. Thank you very much.